In September of 2015, when I was 9 years old, my father had told me about a lunar eclipse coming up soon. The night of the lunar eclipse, we made a campfire and we watched it together. And that year, he got me a telescope for Christmas. And even though it was cheap and you could barely see out of it, it was special to me because it was what we did together. We looked at the stars and the moon, and we even tried to see the planets. And ever since then, I have been fascinated with astronomy. I think that it is important to know about astronomy because it can provide beneficial insights into the necessary workings of the universe. By learning about stellar objects such as stars, it can teach us about the laws of physics and how they shape our world. Knowing about the life cycle of a star can help us understand one of the many processes that shape our universe. As a student who has researched astronomy since she was 9, I believe that it is of the utmost importance to learn about what the universe is made up of. Through exploring the different stages of a star's life, we can obtain great understanding of our universe and learn how to value something we normally see as insignificant, but in reality plays one of the biggest roles in our lives. In space, there are clouds of dust and gas called nebulas, which are basically like stellar nurseries for baby stars, and they are made up of hydrogen and dead star remnants. According to NASA, a nebula can be up to hundreds of light years across. The attractive force of gravity pulls the clouds together, making it become larger. This is called a protostar. When they get big enough, the gravity starts to squeeze the protostar, almost like it's folding itself inwards towards the center. It gets very dense and very hot quickly. The particles trapped inside the protostar start to collide, which makes it even more hot. And then when the temperature and pressure inside gets really high, hydrogen nuclei start fusing together and make helium nuclei. This process is called nuclear fusion, and nuclear fusion gives out massive amounts of energy, keeping the core of the star hot. Some protostars never make it past this point because their temperature never got high enough, meaning they can never fuse any other hydrogen nuclei to make helium nuclei. We call these brown dwarfs, and they are smaller than the sun. However, they are bigger than Jupiter. And they are not considered real stars, but they still shine opaquely for millions of years until they cool down completely. Later on, the star switches on like a light switch and begins to shine. This is the point in the life cycle where we can actually call it a star. More accurately, it is called a main sequence star. In this stage, the inward pressure caused by gravity is balanced with the outward pressure caused by the energy being released by constant nuclear fusion. This is kind of like the fuel for stars, and this is the exact stage of life that our sun is in. Later on, at some point, the star starts running out of its fuel, its hydrogen, and without hydrogen, it won't be able to make any more nuclear fusions. The inward part of the gravity causes the star to bring itself inward, making a small ball. Then when it gets really hot and dense, nuclear fusion starts going up again, causing it to once again expand, except this time it is not only fusing to make helium, it's making heavier elements going all the way up to iron on the periodic table. How big the star gets depends on how big it was when it was first born. If it is the size of the sun, which is a small to medium-sized star, then it would form a red giant. Then if it was a really massive star, then it would form a super red giant. And these stars complete their life cycles completely different. Rather quickly, a red giant becomes unstable. They start to push out their outer layers, leaving a hot and dense core. The core doesn't do any more nuclear fusion. This is called a white dwarf. They give off tons of light, making it appear white and small. And in time, the star gets cooler, making it darker, emitting all of the energy it has. Then it transforms into a black dwarf. It has no energy to give light. And some scientists or astronomers theorize that these black dwarfs may have supernova explosions at some point. Red giants start back doing even more nuclear fusion than before. Several cycles of getting bigger and getting smaller. They will eventually explode. This explosion is so huge that it outshines its whole galaxy. And this is called a supernova explosion. And we can actually see them from Earth if they are in the Milky Way. Supernovas form elements heavier than iron, which expel out all over the universe. Depending on the size of the star determines what happens next. If the star was just big, then it would condense, and it would make a very dense core called a neutron star. And if the star was absolutely enormous, then it would collapse in on itself and become a black hole. Because their core is so dense, their gravity is capable of pulling in any light that passes by. They look like empty spaces or tiny holes in space. Black holes are very hard to study. According to CFA, they don't emit conventional electromagnetic radiation. Their powerful gravitational pull distorts the light, basically making them invisible. And black holes can't die. However, NASA has stated that they predict them to gradually evaporate after a long period of time. To sum everything up, astronomy gives us everything else in the universe life. Learning about astronomy allows us to appreciate everything it does for us. Every stage of a star's life is so astonishing. The birth of a star from a stellar nursery, the protostar being a baby, the main sequence star emitting light, expanding to red giants or even super red giants, to the beautiful, untimely death of a supernova. With exploring the great wonders of the universe, we could attain intelligence as well as respect for its life-giving abilities.